Hello, today I'm going to be going over gravity and freefall. So the objectives of today are to learn what gravity is, learn Newton's universal law of gravitation, learn the differentiation between mass and weight, learn the differentiation between lowercase g and uppercase g in physics, and learn what freefall is. So let's get right to it. Gravity is the force that makes an object come down when you throw it up into the air. So legend has it that when Newton was sitting under an apple tree, an apple fell from the top of the tree and hit his head. Newton knew that this object was accelerating, and because of the second law he made, he knew that you must have a force on this object for it to accelerate. So Newton postulated that there was a force acting on every object on the Earth. He called this force gravity. Furthermore, he postulated that if this force was acting from the tops of trees, it could be the same force that keeps the moon in orbit around the Earth. His next step was to find what exerted this force, and his conclusion was that all objects exert gravity, but the Earth's mass is so great, and thus its gravity is so great, that it's the only non-negligible force of gravity, other than the moon. People back then found it hard to believe this because gravity isn't a contact force. So now let's go over Newton's universal law of gravitation. After figuring out about gravity, Newton set off to find the magnitude of gravity. He concluded with the universal law of gravitation, which is F of g is equal to g times m1 times m2 over r squared. So let's go over what each of these are. So g is equal to 6.67 times 10 to the power of negative 11 Newton meters squared per kg squared. And then m1 and m2 are just the masses of the objects that are exerting gravity on each other. And r is just the distance between m1 and m2. So now let's go over the difference between weight and mass. So these two terms are used interchangeably in everyday life, but these two terms in physics are very different. So mass is the quantity of matter on an object or the measure of the inertia of an object. So weight is the force of gravity on an object. Thus, mass and weight are very different things. So weight is equal to mass times gravity. Thus, you can see that weight and mass are proportional. G is the force of gravity or the acceleration due to gravity, and G is equal to 9.8 meters per second squared. So you can rewrite this equation as weight is equal to mass times 9.80 meters per second squared. Weight is measured in newtons, and mass is measured in kgs. 1 Newton is equal to 1 kg meter per second squared. So now let's go over the difference between lowercase g and uppercase g. So uppercase g is the universal gravitational constant and equals 6.67 times 10 to the power of negative 11 Newton meters squared per kg squared. And the lowercase g is the acceleration due to gravity and equals 9.80 meters per second squared. The two are very different, but they are related. So on the surface of the Earth, your mass or your weight is equal to the force of gravity, which is mg. And we can rewrite Newton's universal law of gravitation as g times m1. This is the same thing. These two things are the same things because these are your mass on the surface of the Earth. Times m of e. This is just the mass of the Earth over r squared. This is the radius of the Earth. R is the radius. So now we can multiply 1 over m1 on both sides. And the m1's cancel out. So you're left with lowercase g is equal to uppercase g times the mass of the Earth over the radius of the Earth squared. So that's how they're related. So now let's go over free fall. When you're in free fall, you're falling with constant acceleration when there's no air. Free fall is what occurs in a vacuum. When Aristotle was there, he believed that heavy objects always fall faster than light objects. However, Galileo said that this is not always true. He postulated that in a world without air, all objects, no matter their mass, would fall at the same constant acceleration and would hit the ground at the same time. This constant acceleration is g, or 9.80 meters per second squared. The distance you fall from free fall is equal to 1/2 gt squared, where g is the acceleration due to gravity and t is your time. So let's use the universal law of gravitation in an example. So you have a mass of 45 kg and you're 5 meters away from a feather of 1 kg. What is the force of gravity you're exerting on the feather? So let's write out the Newton's universal law of gravitation. F of g is equal to uppercase G times m1 times m2 over r squared. So now let's write what m1, m2 are, and r squared and g are. So m1, let's just say m1 is your mass. So m1 is equal to 45 kgs. m2 is equal to 1 kg, or the mass of the feather. R is equal to your distance, which is 5 meters. And g is the universal gravitational constant, and it's 6.67 times 10 to the power of negative 11 Newton meters squared per kg squared. So let's plug these values in. So we have the force of gravity is equal to 6.67 times 10 to the power of negative 11 Newton meters squared per kg squared times 45 kg times 1 kg over 5 meters squared. So now let's erase this to give us some extra space. So we have the force of gravity is equal to 6.67 times 10 to the power of negative 11 Newton meters squared per kg squared times 45 kg squared. If you multiply 45 kg and 1 kg over 25 meters squared. So, or we can write this as m squared. So now let's find out the units. So the kg squared here cancels out with the kg squared over there, and this meter squared cancels out with this meter squared. So you're left with 6.67 times 10 to the power of negative 11 newtons times 45 over 25, and we can just write this as 6.67 times 9, if we make this 9 and this 5, over 5 newtons. And this makes sense because newtons is the measure of force, and force of gravity is a force. So let's try an example of the proportionality of mass and weight. So you have a mass of 45 kg. What is your weight? So let's write out the equation. Mass times acceleration due to gravity. And on the surface of the earth, that's 9.80 meters per second squared. And your mass is 45 kg. So now all we have to do is multiply this out. So we have 45 times 9.8 kg meters per second squared. And this unit is equal to 1 newton. So we have your weight is equal to 45 times 9.8 newtons. And now let's just multiply 45 and 9.8. 490, and you have 360, 3920. So you get 4410, and then you have to move the decimal place one to the right because you have to do the same there. So you get 441 newtons as your weight. And that's the answer. So let's try one last example. You have a mass of 45 kg and you're free falling in a vacuum tube. You've been falling for 4 seconds. So what's the distance you've traveled? So we know that the distance you've traveled because of free fall is 1/2 gt squared. So it doesn't matter what your mass is because there's no place to plug your mass into this equation. So all we need is the acceleration due to gravity, which is 9.80 meters per second squared, and your t, which is 4 seconds. So you get 1/2 times 9.8 meters per second squared times 16 seconds squared, which is what you get when you do 4 seconds squared. And then notice the s squared and the s squared cancel out. So you have 1/2 times 9.8 times 16 meters as the distance you've traveled from free fall. So you get 8 times 9.8 meters. And let's just multiply that out. 9.8 times 8 is 4, 6, 72, 78.4. So You've traveled 78.4 meters when you're free falling. And that's the answer. Thank you.